The ampacity rating of electrical conductors, including copper busbars, is determined by various factors. Firstly, the material. The electrical conductivity of the material is a key consideration, and copper has high conductivity. Secondly, the cross-sectional area. The larger the cross-sectional area, the greater the ampacity. Thirdly, ambient temperature. Higher temperatures reduce ampacity. Fourthly, the cooling method. This includes natural convection and forced air cooling. Here is an ampacity table for quarter-inch copper busbars with a thickness of 0.125 inches. For natural convection or open-air cooling, the approximate ampacity is 125 amps. For forced air cooled at 40 degrees Celsius, the approximate ampacity is 160 amps. For water cooled, the approximate ampacity is 215 amps. These values are for reference only and should not be used as the sole basis for design. Actual ampacity ratings may vary depending on specific conditions and should be determined by a qualified electrical engineer. The general formula for calculating the ampacity of a copper busbar is ampacity equals cross-sectional area times current density times temperature correction factor, where cross-sectional area is in square inches, current density is in amps per square inch, and temperature correction factor is a multiplier to adjust for ambient temperature. For copper busbars, the current density for natural convection cooling is typically assumed to be 600 amps per square inch. Now for an example calculation to determine the ampacity of a quarter-inch copper busbar with a thickness of 0.125 inches in natural convection cooling. Cross-sectional area equals 0.25 inches times 0.125 inches, which equals 0.3125 square inches. Current density equals 600 amps per square inch. Temperature correction factor equals 1 assumed. Ampacity equals 0.3125 square inches times 600 amps per square inch times 1, which equals 18.75 amps. The ampacity rating of quarter-inch copper busbars depends on the cooling method and other factors. The provided table and formula can serve as a guideline, but it is recommended to consult with a qualified electrical engineer for accurate ampacity calculations and design considerations.